Hi guys, this is for Unit 5A and 5B study guide. All right, so let's look at number one. We're dealing with systems and we're going to go ahead and graph them, okay? So let's start with the first equation that we have here. Y is less than negative 4x plus 3. Okay, again, start with your y-intercept, okay? That'll be at 0, comma, positive 3, so go to 3. There we go. And then our slope or rate of change for our graph will be down 4 over 1. Okay, so because again our rate of change is negative 4. So that means down 4 because negative 4 equals negative 4 over 1. All right, so you go down 4, okay, and then run uh, 1. Okay, so go down 4, 1, 2, 3, 4 over 1. So that will be our second point. And now the question is this dotted solid for the boundary line? So it looks like our inequality does not have a line underneath, so it's just less than. So it is dotted, okay? So we go ahead, just make sure you try to draw your boundary line as accurate as you can, okay? And wow, that's not a very good line, but hey, it's all digital. All right, so now the next question is, do we shade up or do we shade down? So y is less than, so we shade down. So we'll shade down. Think of it as a roof, okay? And I'll go ahead and talk about this in great length, okay? Y is your roof. If your roof is less than the snow, which means your roof is weaker than the snow is going to make inside your roof. And let's say, your boundary line here, okay? The dotted boundary line is your roof. And here's your roof protecting you from the outside. But your roof is too weak and the snow makes it into your cabin. Okay, and there's you with your coffee or hot cocoa, and now there's snow in there, so goodbye, hot cocoa. Okay, so that's the idea um, about that. So, again, let's talk about the methodology. I just want to make sure you get that. Okay, so again, what's your y intercept? Okay, when you're graphing. So, that's the first thing. That's what you look at, your B. Okay, second, your rate of change. Again, that's your M, your slope. And then third, dotted versus solid boundary line. Okay. Be aware of that before you graph your line or draw it. And then fourth, uh, shade up versus shade down. So make sure you understand those are your 4 steps when you're graphing inequalities. Okay, so we did our first equation. We're going to do our second one. Y is less than negative x plus 3. Okay, so again, first step, y-intercept. What's my b? It's 3. So 0, comma 3 is right there. Okay, and then our slope is negative 1x. So it's negative 1. So negative 1, remember, is the same as saying negative 1 over 1, right? So that means you go down 1 and run 1. Okay, so down 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1. Notice I'm just keeping that rate. Now is it step 3, dotted or solid? Okay, it's dotted. Okay, there's no equal to. All right, so it's just less than. So again, dotted, dotted boundary line. There we go. Let me go backwards. There we go. And now 4, okay, shade up or shade down. It's less than, so your roof is weaker than the snow. Again, here's your roof, your y's, and your snow is the functions, all right, the expressions. So if your roof is less than the snow is going to break through the roof, okay? So we'll go ahead and graph that. So we shade below. Again, I'm only focused on the blue equation. I'm not worried about the red guy. Right now, I'm just focused on the blue guy. Okay. So again, when we're thinking about solutions, so in this part and part B, okay, so we already finished part A. We went ahead and graphed it. Okay, we graphed both of them. Um, but now what we're trying to figure out or determine is solutions. So if we go to part B, is 0 comma 3 a solution? So if we go to 0 comma 3, that's right here. Okay, that's what they're asking is that coordinate a solution? Now, notice how both boundary lines are actually dotted. So technically, uh, anything on either of those boundary lines would not be a solution. So remember when we had a dotted boundary line and you had a coordinate that was on it, that would still be false. Okay. And if you actually consider both situations, y is less than for both of them. So 3 is not less than, it's exact. Okay. So 0 comma 3 is not a solution. Okay. It's false. Um, since it lands, okay, and I'm talking about the solution, 0 comma 3, it lands on a on both boundary lines, but on a dotted boundary line for both equations. So be aware of that. All right, is negative 1 comma 1 a solution? Let's try it. Negative 1 comma 1. Aha, that is totally true. Okay, because again, it's where both shaded regions are both uh, layered on top of each other. So if you can tell where you're standing here with a cup of hot coffee, um, both roofs failed you. All right, the snow made its way in, and as you can see, there's blue and red in that area. So if you actually realize all inside this area is true, okay, because both the blue and the red are shaded in. So um, is it a solution? Yes. Come on. Negative 1 comma 1 is inside the double shaded region. Okay, that's true. Remember, you need food and water to survive. Okay, so negative 1 comma 1 would be a true statement in that sense. All right, if you think about any other areas, okay, they would definitely be false. So just consider that. All right, so let's look at part D. Is 1 comma 3 a solution? Okay, 1 comma 3. If we try that, it's up here, and I already said that area is false. So no, it's not a solution for the same reason. It's not inside the double shaded region, right? Not inside double shaded region. There we go. All right, number 2, honestly, that's homework. Get some practice in, okay? Be aware of your signs, your symbols for your inequalities, that is less than or equal to. So is that going to be dotted or solid? All right. Again, your first step, what's my B? What's my M? All right. Go ahead and graph both of them. Okay. That's part E. And then see if these are solutions or not. Make sure you explain why. Okay. All right, number 3. Anna is buying a total of 25 fruits and vegetables for her garden. Nice. Vegetables are $2 per item. That's something I should probably note. And fruits are $4 per item. Okay. Anna spent 60 bucks. Let's see. And she's buying fruits and vegetables for her garden. Okay, so that's something to note. All right, so create a system. We got fruits and vegetables. All right. And she got, ooh, missed that, 25 of them. All right. She got 25 of them. We know that vegetables are $2. per, okay, 2v, 2 per vegetable, and $4 per fruit. So $4 per fruit. She does spend $60. All right. So it looks like there's my system. Part B is asking how many vegetables did Anna buy? Well, let's solve for vegetables. All right. So we need to eliminate fruits. All right. So let's go ahead and try to solve that. Um, you can use elimination if you want. I'm going to go ahead and use elimination. It's one of my favorites. So I need to eliminate my fruit. So I'm thinking, what do I not need to multiply? And let me erase this chunk right there. I'm already thinking, what times the top part can get me a negative 4f? Because I want to eliminate the positive 4f, right? So if I multiply by a negative 4, okay, and I distribute, it'll give me a negative 4f. Okay, I'm distributing here. And then negative 4 times v, which is negative 4v, times the negative 4 with the 25. It's a negative 100. And let's see, I have that 4f down below. Got that 60 here. Okay, again, we didn't change the bottom. And now I'm going to go ahead and eliminate by addition. Okay, so this is actually multiplying first. All right, so if I was to add, these would eliminate like we wanted. We get negative 2v here, negative 440 right there. Use a division property, and we get v equaling, what's a negative divided by a negative? That should be a positive. Vegetables equals 20. All right, good. So Anna bought 20 vegetables. Vegetables, if I can spell that. Sorry, it's late. How much do they cost? Well, didn't we say it was $2, right? $2 per vegetable. So 20 times 2, right? Um, so it costs $40. All right. Now, how many fruits did Anna buy? Well, we already say that vegetables was 20. So let's plug it back in. Our first equation, right? Our original equation, f plus v equals 25. So we're going to use that. All right. So we had fruits, we don't know how many, plus vegetables equals 25. Well, we said that there's 20 vegetables that she bought. So how many fruits is that? Subtraction property. And already you should be able to see that fruits cost, or I'm sorry, not fruits, cost, but fruits are 5. So Anna bought or purchased 5 fruits. How much did it cost? Well, we said that fruits were $4 per item. Okay, so 5 times 4, that should be $20. Which makes sense. If you double check the math, she did spend $60. All right. So 40 plus that 20 checks out. 60 bucks. All right. So similar situation for number 4. Different numbers, different things. I would definitely use S and W for soda and water. And I'd pay attention to what they're talking about. They give us some numbers. Create a system, just like in the previous problem. And then try to work with this with your group. Okay, I actually want you guys to put it up on the board, talk about it, try to get some discourse in your day. Okay, so and again, number 4 is for you. All right, number 5, determine the most efficient way to solve the system, then solve. All right, so which method would you use to solve the system? All right, well, I already see that y is isolated right here for my system, so I would use substitution. Okay, I want to circle that. I would solve by substitution. It'd probably be more efficient. Now, why? I could just plug it back in. All right. So don't forget we're going to solve it. So let me explain what I mean. Y is already isolated. It says y equals 3x plus 4. So I'm just going to plug it in to my other equation. I got 7x minus 2y. And didn't they say y is 3x plus 4? So notice how I'm just substituting in for my y. It's still equaling the -4, like I said. I want to go ahead and distribute. Okay, I'm going to get 7x minus 6x, because -2 times positive 3x. -2 times positive 4 is -8. I'm going to go ahead and combine like terms. Okay, and then I'm just going to work on isolating my x. So how do you get rid of a -8? Plus, and then what you do to one side, to the other, x equals 4. Okay, so that's part of my answer. Remember, I'm looking for a solution, which is really just an ordered pair. So I'm going to plug back in 4 for my y. Okay, now like I said, they already have y isolated in the first variable, or the first equation. So I'm just going to go ahead and use the first equation. Y equals 3x plus 4. We already said that x is actually just 4. So 3 times 4 is 12. 12 plus 4 is 16. So look at that, y equals 16. So my solution is actually at 4, comma 16. So again, substitution is what I chose, since y is already isolated. There we go. So again, that's the method I chose, because again, y was already isolated in the first part. So just plug it in, solve for x, plug whatever you got in for x, okay, and then you get y. So x comma y. All right, number 6, which method would I choose? Okay, notice how they're both in standard form. Okay, they're both in that whole ax plus by equals c format. Um, so I'm already thinking, okay, I'm probably going to use elimination or multiplication, then elimination. I notice that if I was to add, notice how the -9y is opposites with the positive 9y. So I'm actually going to just use elimination by addition. Okay. Okay. So the reason again is because I notice if I was just to add, the y's, they cancel out. Okay. So if I add it, I get 4x. The y's cancel out, like I said. And then we get 20, division property. So 20 divided by 4. And you get x equals 5. Then I want to plug it back in to whichever equation I want. Tell you what, I'll plug it into the first equation. Actually, the second. Second one's a little bit easier because your coefficient is just 1x instead of 3x. So I'll plug it back into the second equation. So it'll be x plus 9y equals 14. X is going to be 5. And then subtraction property, you get 9y equals 9. Division property, and y equals 1, because 9 divided by 9. All right, so our solution is at 5. Again, x comma y comma 1. There we go. So again, I chose elimination by addition, since the y terms would instantly eliminate. Okay, by addition with elimination. So that's just being strategic. You could rewrite them all and then set them equal to each other, like y equals this, y equals that. We could do that if you want. It might be a little bit more algebra, but you still get the same answer. All right. Lastly, number 7, if you notice, if you add or subtract, the x and y terms don't eliminate. If you subtract, you still get 1x. You still get -3y. If you add, you get 9x, and then you get 9y. They don't eliminate. So I'm going to go ahead and think about multiplying one of our equations first. I notice that 3y and 6y, 3 and 6 are factors of one another, and I know for a fact if I multiply the top by a 2, more specifically a -2, it'll get me the opposite of a positive 6y, which would eliminate a lot easier. If I wanted to eliminate the x terms, I would have to eliminate or multiply both equations. So that's double the work. So I'm going to go ahead and just focus on eliminating y since I know multiplying the top guy by -2, um, I'll be able to eliminate one of my terms, which is what I want. All right, so again, I eliminate. I distribute first, so I get -2 times 5x, it's -10x. I have -2 times 3y, which is -6y. I have -2 times 13, -26. I did not change the bottom equation. And now I'm going to add uh, with elimination. So notice how I get my y's to be opposites of each other. I get -6x equals -12, division property, and I get x equals +2 because negative divided by a negative. And now I just plug it back into whichever equation I want. I'll pick the top one. Why not? So instead of 5x plus 3y equals 13, I'm really plugging in for x, which is 2. So 5 times 2, okay, plus the 3y. Sorry, that's a terrible 2, I know. Equals 13. It gives me 10 plus 3y equals 13. Subtraction property. Just make sure what you do to one side, you do to the other, and then you get 3y equals 3. Division property. 3 divided by 3 is 1, so y equals 1. So my solution, again, is at 2, comma 1, okay, x, comma y. It's an ordered pair. And then I chose to multiply first. Now, why did I choose that? Well, um, addition by elimination or subtraction elimination wouldn't work right away, okay? And I saw that 3, okay, 3y and 6y were factors of one another. And I knew if I was to eliminate a 6y, I would need a -6y. And I knew -2 times a 3y would get me a -6y, which allowed me to get to here. Okay, so I chose to multiply first. They are already set up in standard form. So I figured, hey, this would be a little bit faster. All right, guys, so that was the end of the study guide. Again, know how to solve in all the different ways, even by graphing. And then, yeah, so again, remember solutions and all that jazz. All right, thank you guys. Have a great day.